Hey there, fellow sky gazers. Have you ever looked up at the night sky and witnessed the mesmerizing dance of colors known as the aurora? Today, we're diving deep into the magical world of auroras, specifically exploring why these stunning light shows grace the skies of the polar regions. So, what exactly are auroras? Well, to put it simply, they're a natural light display caused by the interaction of charged particles from the sun with atoms in the Earth's atmosphere. But there's so much more to it than that. Let's start with the basics. The Earth is surrounded by a magnetic field, kind of like a giant invisible shield. This magnetic field protects us from harmful solar radiation and cosmic rays. However, near the North and South poles, the magnetic field lines are inclined towards the Earth's surface, creating what we call the magnetosphere. Now, here's where things get interesting. The sun constantly emits a stream of charged particles known as the solar wind. When these charged particles interact with the Earth's magnetosphere, they get trapped and channeled towards the polar regions. As these charged particles, mostly electrons and protons, enter the Earth's atmosphere near the poles, they collide with atoms and molecules, such as oxygen and nitrogen. These collisions excite the atoms, causing them to release energy in the form of light. Different gases produce different colors when they release this energy, which is why we see a stunning array of colors in auroras, including greens, blues, reds, and purples. Now, let's talk about why auroras are predominantly seen in the polar regions. One of the key reasons is the angle at which the charged particles enter the Earth's atmosphere. Since the Earth's magnetic field lines converge near the poles, the charged particles have a higher chance of interacting with the atmosphere in these regions. Another factor is the density of the atmosphere. The atmosphere is thinner near the poles compared to the equator. This means there are fewer molecules for the charged particles to collide with, allowing them to travel deeper into the atmosphere before they lose their energy and create the auroral light. But wait, there's more. The intensity of auroras is also influenced by solar activity. You see, the sun goes through regular cycles of activity, with periods of high solar activity known as solar maximum and periods of low activity known as solar minimum. During solar maximum, when the sun is more active, there are more solar flares and coronal mass ejections, which send a higher concentration of charged particles towards Earth. This increased influx of charged particles can lead to more intense and frequent auroras, sometimes even visible at lower latitudes than usual. Now, let's address a common misconception. Many people believe that auroras only occur at night. While it's true that auroras are often more visible in the dark sky, they can actually occur during the day as well. However, they're usually overshadowed by the brightness of the sun, making them difficult to see unless you're in a location with extended periods of twilight, or if the aurora is exceptionally strong. Speaking of visibility, the best time to witness auroras in the polar regions is during the winter months, when the nights are long and dark. This extended darkness provides ample opportunities for sky watchers to catch a glimpse of these celestial marvels. Now, let's shift our focus to the different types of auroras. The most well-known type is the aurora borealis, also known as the northern lights, which occurs in the northern hemisphere. On the flip side, we have the aurora australis, or southern lights, which dazzle observers in the southern hemisphere. But did you know that there are also other types of auroras? There's the pulsating aurora, characterized by rhythmic brightening and dimming of the auroral arcs. Then there's the diffuse aurora, which appears as a faint glow across the sky. And let's not forget about the rare and elusive strong thermal emission velocity enhancement, auroras, which display a distinctive purple and green light. Now let's address a question that's probably on your mind. Are auroras harmful? Well, for the most part, auroras are harmless and simply a breathtaking display of nature's beauty. However, during intense geomagnetic storms, which can accompany strong solar activity, auroras can be accompanied by disruptions to radio communications, satellite operations, and power grids. These geomagnetic storms are rare and typically only pose a significant risk to technology rather than to human health. So, there you have it, folks. The captivating auroras that grace the polar skies are a result of the intricate dance between the sun, Earth's magnetic field, and our atmosphere. From the dazzling greens of the aurora borealis to the ethereal purples of the Steve auroras, these natural wonders never fail to inspire awe and wonder in those fortunate enough to witness them. As we wrap up, I encourage you to keep looking up at the night sky. Who knows what other celestial marvels await our discovery? Until next time, keep exploring and stay curious.